to NetLabs Hub. Today I'm going to deal with NAT, types of NAT, explain why we use it and where to use it using a simple Packet Tracer configuration lab. And here it is. We are going to cable. So we are going to start with the static NAT. Static NAT, that is network. Let me cable the simple topology here. This is the router 1, then it is connected to this. Let's just say DNS. Then this router is connected here on the switch. Then there is one laptop. So this is the topology that I'm going to use to help you learn about NAT, basically static, where one internal IP address is mapped to one public IP address. And this case is mostly happen when the computer is mapped to access web servers or specific servers in the cloud. Let me show you the guide here. So these are the basic guide that I wrote just to help you understand. This is the protocol that was designed to be in place to help the exhaustion of IP address, IP version 4 address. So this is one of the way that helps IP version 4 address not to deplete, or the time it was depleting, this was a mechanism that was kicked in to ensure that at least we do not waste or misuse the IP version 4 address. We've got other ways like dual stack, whereby a machine is configured with 2 IP addresses, that's IP version 6 and 4. We've got other methods like this is it. So we've got types of NAT. As you can see, why NAT is used. We use NAT to conserve IP version 4 addresses, because IP version 4 address, due to the connectivity, due to many devices that have been connected to the internet, the invention of IoT and other things, you find that there is depletion of the space, IP version 4. So to maintain that IP version 4 is not yet depleted, or to maximize on the proper utilization, NAT was kicked in to help conserve such. So we've got types of NAT. We are going to start with the static NAT, whereby one private IP address is mapped to one public IP address and vice versa, so that devices can communicate on different networks, from internal network to the internet, from the internet to the internal network. Two, it helps to at least to add a layer of security whereby internal IP addresses are hidden from the outside, vice versa. Allows also private networks to access public networks. As you can see in this topology here, this user, let me write here user. This user can access this DNS server. Then the DNS server can still access this one through using the interface gigabit 0/1. So this section, let me just highlight the internal network. This section, that section that I have highlighted, that is the internal private network, and this section is the external network. So, and the internal network is serving on this subnet 172.16.10.0/24. Let's be back here. So this is reasons why we use NAT to conserve IP version 4 addresses, to add a layer of security to the network, also to allow access of private network to the public and vice versa. It also enables multiple devices to share one public IP. Multiple devices can share one public IP. It means that multiple users in the internal network can at least use that public IP to access the resources. For example, we've got terms here. These terms you should be familiar with it. And here I have tried to explain them here. We've got inside local. This is the private IP address of the device. For example, in my case, this one, I'm going to give it 172.16.10.10/24. So this is my inside local. Let me assign that IP to this machine statically. So 172.16.10.10/24. So the gateway is .1, then the DNS is 265.110.2. So that is it. So my inside local is 172.16.10.10. Okay, let me be back here. So inside global, public IP address representing inside IP. So in my case is the IP address for the DNS server or the web server. Outside local, IP address of the external, IP of external devices as is seen internally. Outside global, real public IP of the external. This is the mostly for the ISP. So these are the terms you should be familiar. We've got inside local, inside global, outside local, outside global. We've got types of NAT. This is where our concern is. And today in this lab, I'm going to deal with static NAT. As you can see, it maps one private IP address to one public IP address permanently. And the use cases where it is used mostly in web servers, in mail servers, FTP servers, and DNS servers. Generally, it is used to help the private users to access the DNS or servers that are hosted in the cloud, far away from the cloud, from the private subnets. So this is it. Let's configure this. These are the steps to configure static NAT. Step 1, cable the network as seen. Step 2, assign IP addresses. Step 3, enable NAT on interfaces. Step 4, test and verify reachability. This is step 5. Step 4 here, configure static IP2 public IP address, then 5 default route, then 6 reachability. So these are the steps that we are going to use to achieve this. So I'll start. I have assigned already an IP address on this, so my switch, I'm not going to do a lot of the switch, but just to do basic configuration. Configure terminal. Host name, we set the host name of the switch, switch 2 underscore, maybe the switch is in warehouse, then switch 2. Banner, message of the day, no intruders. Loud on the network. We close, then end. For security reasons, I'm going to shut all unused ports. Configure terminal, then interface range, fast Ethernet 0 to 0 up to 20. Shut down. Description, unused. Then I save. I told you in my previous labs techniques for save. In privilege mode, you write memory, then it will save, or WR, it will still save. For another method, you will do copy, run, start, still it will save. Or in full copy, running, startup. It means I'm copying my running configuration file to startup file, so that upon my restarting the router, my configs won't be lost. So that is it. So let me come here and assign the IP address on this router as the second step, and this is the third step. So no, enable to move to privilege mode, clock set, this is 11:55, 31st Jan 2026. Config terminal, host name, main router 1, then interface gig gigabit 00, no shutdown. We describe the interface, main interface. After there, we assign the IP address on 72.1.255.255.255.0. I have assigned the IP address on that interface. That is step 2. Then I enable NAT. begin while I'm doing this because it is one of the areas that have failed many engineers on the ground and many technical people in this networking field. So to enable this interface, because this interface is facing the inside the network, I say IP NAT, then as you can see we've got inside the interface for address translation, outside interface for address translation. So this is my interface inside. I can describe it facing organization LAN. That is it. So I'm done. I have enabled NAT. By doing this, by doing IP NAT inside, I have enabled network address translation. Next, so I move to this interface gig0/1. There is one thing I have failed to do here. So config interface gig0/1, no shutdown, then IP address 200.65.110.1 255.255.255.252, because I just want two IP addresses on the router side and on the server side. So after that, then I enable this interface. I enable NAT on this interface, but to the outside. So outside, once I have done this, then I exit. Let me save my configuration or else they will be lost. Copy run startup. That is it. That one. So I'm done. I configure the let me unshut. The interface facing the LAN was not up. So let's check what is the issue. It's not coming up. The reason this interface is not coming up is that I shut a port that is within that range, so I give it 21. First 20 ports I shut it down, so that is it. The interface is now up. Let me assign this 200.65.110.2. I want it to be /30, so it is 252. Then the gateway, that is 1. Then the DNS, it is 2 still. So let me configure the DNS. I turn the server on, netlabs hub.com, then the IP address, then I add, it's okay. Once I have done this, the remaining part is to configure the IP now to map my internal IP to the external IP. This is 10, then this is 2. So I do this, exit, then IP NAT inside. From inside then source, as you can see from there. Static, we don't list. List is used mostly when you are configuring dynamic network address translation. After this video we will do the dynamic, then we will finish with the part that is port forwarding or port address translation, whereby we maintain one public IP vis-a-vis many IP addresses internally but alongside the port. So I have not finished this command static. So as you can see, if you don't remember what is following next, you just give a space, then question mark, it will give you the IP address. So I'm mapping this IP to 265.110.2. You see, I have done. So once I have done this, I have conditioned that my computer inside network, it will be translated to 200.65.10.110.2. So after that, I create the default route. Now I allow the internal computer or the private network to access the internet or the interface facing the internet. So I will do this by doing IP route space IP route, then all my internal network. So that is this one space the entire network, then the entire subnet, then from there the IP at the interface. You can see forwarding router's address, dialer, ethernet, or gigabit loopback, or that is, so we can from here we can say 200. Let's put it here. Then check distance metric for the route. You can give it 10. Then write. So I have finished configuration, mapping this IP to external to my IP. This is it. So this, my DNS is having this as an IP address, this /30. So as you can see, let us now try to ping. We start with internal network 172.10.1. It is working, so my computer can ping the gateway. So from there, can it ping the interface facing the ISP or facing the server 110.1. You see, it's pinging. So this is how we configure this. When we do that, we can check. Let me check first one thing here. Let me try to ping the server if it is reachable. So let us check reachability. On the aspect of reachability, this one is able to reach here. It is able to reach to this subnet. So let us check test whether it is translating or show IP NAT. You can see it is both the statistics, what has been done. As you can see, total translation was 4, 1 static, 3 dynamic, 3 extended. Outside interface is gig 0/0/1, then inside interface is gig 00. So as you can see, my NAT is enabled on this network. This is my outside interface. Gig 0/0, it's my inside interface. So I have tried to ping, so let me show these are methods to verify NAT. show IP NAT, then translation. You can see, as you can see, this is, we've got inside global, inside local, then outside local, then outside global. So we've got, this is our inside local. It has been transitioned or translated to outside global. So NAT is working, and that's how we configure static NAT. Though in a complex network, static NAT is not used because there is no, the network is so big we cannot map one host to each public IP. So it's like we will be misusing the public IP. So as technology has revolutionized or advanced, now we moved to other types of NAT whereby we can use the dynamic or the port address translation, where we just use one public IP then appended with some unique ports, so that such ports can serve as tunnels for communication from the internal hosts. So that is it. Thank you so much for paying attention. If you feel that this lab helped you to learn something, you can just comment, subscribe, like, and share. Or if you want these files also, just comment your email. I'll be able to share with you this guide. Thank you so much.